And let's get it up on the chat. Oh boy. Get the Twitch open. And while I'm getting it open, no theme song today, but maybe I'll hum something for you. I woke up with you on my mind. Then I realized it's 'cause you're my baby. And when I want you by my side. And you wonder why. It's 'cause you are mine. Oh, cool, we're live. Hello, everyone, and welcome to Topical, Tech's best talking show. I am your host, Brian Ross, and today we have a very special episode, as we always do, but we don't have any guests, because who needs guests, right? I've decided from now on, just a solo show. Me and only me. That's all you need, right? No, in actuality, we had someone who was going to come, then they couldn't come. It's one of those things. So not even worried about it. Today, what we're going to do instead is learn about blockchains. Every episode, it feels like we've talked about cryptocurrency, we've talked about blockchains, we've talked about NFTs, we've talked about all these different things that are sort of encompassed and encapsulated by this term blockchain. And not going to lie, after every single one of these episodes, not some of them, every single one, someone has asked me, what is blockchain? And it sounds like that's a question that really wouldn't be asked, at least to me, or at least to you, expert in blockchain matters, because you would feel like most people kind of have heard about it. They know what it is. They know about Bitcoin. They know about, all the different things that come with blockchain, or at least they have some sort of idea. However, viewer, a lot of people don't know about blockchain, shocking the audience. And this episode is going to solve that for everyone. After this episode, everyone in the world will know what blockchain is. At least they should. They have no excuse. You don't know what blockchain is? You didn't watch Topical? What's wrong with you? No. Okay, so today we are going to learn about what a blockchain is. Let me make sure I have the chat up. You see, every so often when I go live, it kicks me off, and then it brings me back on. Okay, there I am. Let me watch an ad first. There you go, Mr. Bezos. I hope you enjoy your 0.001 cents of me watching this ad. What is today's ad? I wish I could choose my own ad. If I could pay to have my own ad on my own show. But I guess I could just run my own ads for free. Yeah, I would just actually run my own ads on my own channel for free if I wanted to do that. So never mind. Don't let nicotine addiction control you. That was today's message. Okay, here we go. And now it's live. I have the chat. Make sure if you have any comments, questions, or concerns to put so in the chat, and we can go ahead and start learning. So we have a very interesting video today. Today we have a video, and the point of this video is they're going to explain blockchain. You've probably seen this before, and they're gonna explain blockchain at 5 different levels of difficulty. Okay, so they're going to explain it to a 5-year-old, and then to a teenager, and then to a college student, and then to a graduate student, and then to an expert. And we'll see the different levels of complexity. And the reason why I picked that is because you could be, dear viewer, either a 5-year-old or an expert, and I don't know. So we'll have this video. We'll get everyone on the same page first. Maybe I'll pause it and make funny comments, as I like to do. And afterwards, I'm going to make a smart contract live on stream. And it's going to be a good time. At least I hope so. I hope you enjoy it. Anyway, so what is a blockchain? Now we can finally, once and for all, answer this question. And let's go ahead and let's run it. Let's see here. Blockchain expert explains one concept in 5 levels of difficulty. And it's on Wired. Okay, here we go. And I hope you can see this. And
my name is Bettina Wilberg. I'm a researcher of transformative technologies and co-founder of Animal Ventures. Today, I've been challenged to explain one concept at 5 levels of increasing complexity. My topic is blockchain technology.
Wait a second. Hold on. Let me rewind real quick, because I have a theory. Okay. Let me make sure the child. My theory is, the more facial hair you have, the more of an expert you are in blockchain.
And co-founder of Animal Ventures.
Let's see here.
Today, I've been challenged to explain one concept at 5 levels of increasing complexity.
Yeah, level 5. Level 5 has facial hair. Is that a coincidence? I guess it is. Good, because the host here doesn't have any facial hair, so I guess never mind. Anyway, here we go.
and it's going to help us decentralize trade, allowing us to do a lot of our transactions much more peer-to-peer directly and lower our use of intermediaries like companies or banks maybe. I think today everyone can leave understanding something about blockchain at some level.
That's the goal. Everyone can leave here today learning something about blockchain at some level. I hope you don't mind, Wired, that I'm hijacking some of your content, but I'm going to add on to it, so that it's totally cool. You can hijack Tech Topical if you want. Only the ones that I'm into. And you have to pay me.
Do you know what we're going to talk about today? It's called blockchain.
What's blockchain?
That's a really good question. It's actually a way that we can trade. Do you know what trade is?
It's when you take turns doing something. It's when you give up most of what you want, right?
When you give up most of what you want? Well, sometimes that definitely happens,
Pepper.
For sure. What if I told you that
Pepper's been left holding the bag sometimes, I guess.
there's a kind of technology that I work on?
Someone has been not teaching Pepper the art of negotiating. Okay, my bad.
That means you could trade with any kid all over the world.
Really?
Yeah.
If I could trade with any kid, I would trade. Well, I would trade something I don't like so much.
That's probably a good idea. Maybe somebody else likes it more than you do. So normally, when people
Smart.
trade, they
Smart,
have to go to
Pepper.
the store or they have to know the person so that they can get what they asked for. With blockchain, you can make that exact same trade, but you don't need the store, and you don't even necessarily need to know the other person.
Well, that was nice. I'm not sure
Ian, do you know what blockchain is?
if Pepper really got it, but
Have you ever traded or sold anything?
Actually, I'm selling my computer on eBay right now.
That's amazing. What made you decide to trade on eBay?
Well, I mean, I've heard of it, and I
okay, so this
trust
is
it a
level
lot
2.
because they have like all of their guarantees, so I know that I'm gonna get money, and the person's gonna get what they want.
So what if I told you that blockchain technology is basically a tool where you can do the exact same thing, but it goes to you and I directly. You wouldn't need an eBay or a brand in between.
That's cool.
And there's a lot of
You
those
see it?
kinds of middlemen.
I think that's kind of the best way to explain it right there to the 13-year-old is it's we get rid of the intermediaries. It's sort of, I mean, yeah, you get rid of the intermediary, but you still need something in the middle. I mean, you still need like a network, or you still need some sort of platform like a Coinbase or something to be able to have these transactions go on. But the core of it, we don't need them. We could do blockchain without all of that, but no, I think the way she's explaining it here makes a lot of sense. Like if you can get this level of difficulty, then you'll be good for everything else. The 5-year-old explanation, that's not bad either. Actually, if you get the 5-year-old explanation, it lets me trade with me to you, and I don't need to have the bank tell me yes or no with my money. We can just do it like how we would do it with cash. Like I just give you cash, etc. Something like that.
In our society today, right? We have a lot of banks, we have a
Yeah.
lot of companies that sort of help us make sure that our trades happen. But if we could guarantee the same trade using technology as sort of like a technological trust, then we wouldn't really need all those middlemen in between.
So how does it work?
It's basically
Yeah, how does
a
it work?
network of computers that all have the same history of transactions. And so instead of sort of there being one company with one database that holds all the information, the same sort of list is held by all these different people. Like you could have it on your computer. And then it gets validated by everyone. And basically that turns into the next part of the list. So it's sort of constantly updating itself.
So like, how do you make sure that it's secure?
So it uses cryptography. And
These are good
that
questions.
helps it basically encode all of
Good for him.
transactions. So you can't really see exactly what happened, but you know it happened because it's like a marker.
So you could kind of like, I don't know, say you trade apples, but you would just see like random letters
Yeah,
for it, so you wouldn't
exactly.
be able to like track it, I guess.
Exactly.
That's cool.
So it's kind of this like really
How did he put that
big
together?
ledger
Good for him.
or accounting system for all sorts of things that get traded, but instead of being owned by one company, it's owned by everybody.
That's cool.
Yeah.
I think that was
We're
a
going to
Smurf.
talk about block.
I think that was a Smurf. I think he knew about it before. That apples analogy. Really good job out of him. Kind of I don't know if 13-year-old me would have been able to come up with that right there. Good for him. I hope he sells his computer for a lot of money.
blockchain technology. Have you heard of blockchain?
I've heard of the words blockchain, but I'm not sure I know what it is.
So when we were much smaller societies, you and I could trade in our community pretty easily. But as the distance in our trade grew...
So this is an economics student. So we would imagine that this person understands like the economic side of it, probably not the code side. So that makes, I wonder if it would be different if you tried to explain it to like a theater major or something. You'd probably have to use different analogies. Or maybe if you did it in song.
We ended up inventing institutions.
Because of theater?
Right?
I don't know.
You use Uber, or you use Airbnb, or you use Amazon even. These are just digital marketplaces and platforms that help us facilitate an exchange of value. But today, we actually have a technology that allows us to trade one-to-one, but at scale, and it's called blockchain technology. There is some kind of interface for it. You could have an app, or you could use your computer to do it. But instead of there being a company in the middle, or what's helping you make that transaction, is a bunch of software code. Okay. And so it's being run by all of these different computers that have like a node. So they're all running the same software and
node, you
guaranteeing
say?
Your transactions as they happen.
I mean, I would assume this technology is taking away business or activity from these middlemen.
In some cases, yeah, it is. And a lot of people in the financial industry in particular are looking at it from the banking side of how do we use this technology to trade things like Bitcoin or other tokens that are easier to use instead of today's currency. A lot of people think about blockchain as Bitcoin because it's sort of in the news a lot and it's this new cryptocurrency and it's kind of exciting, but we're actually seeing a lot more use cases for blockchain that aren't around the currency side. They're more around how do you take any asset and be able to trade that using this same technology.
Okay. More layers of distinction.
Is there a mechanism for verifying that person A is a legitimate seller or producer of the item?
So today, a lot of people are working on how to create identity structures that leverage blockchains. And one of the tools for doing that is being able to cryptographically sign for a given attribute. So your government could sign that you have a US passport, or a university could sign that you are a currently enrolled student. And you could then dole out that information and control it yourself and be able to show people those certifications on an as-needed basis.
What if Make School do
that
one
day? So
day?
today we're going to talk about blockchain technology.
Okay, so that was college students. So now we're going into graduate students. So now we're getting into the intellectual heavyweight. So he's an economics PhD student at Fordham University. Okay, so it seems like we got most of it with those first two. And then the third one, we started to get into more levels of distinction. So not only is it like a way for us to trade, but it's also blockchain, at least, is not only a way for us to trade, but it's also a way for us to trade not just currency, but also other types of digital assets in this. Conceptually, it's a peer-to-peer thing, right? Like I can send it from me to you, and we don't have to worry about anyone else. We just have to worry about the validators, the node validators, the other people. They'll probably explain it to Valentina's here, but the different people who are mining and validating these transactions. But I think if you got those first two, then you're pretty good. I bet you these last two are going to be a little bit more complicated. That third one, you probably are following along. Let me know in the chat if you have any questions. All right, let's see what they have to say to Valentina's.
Okay.
Have you ever heard of blockchain?
I have. Whenever we have a transaction, and let's say I buy something from you, this information gets logged and it gets verified by a third person or third party. And then if all this information verified and it all matches, right, the transaction goes through without any intermediary, basically, right? And it gets stored. And when we make further transactions, this information is already embedded. It's in the ledger.
Yeah, that's exactly right.
Yeah,
and you can
he knows what it is.
You can sort of add new information that's more current. but you can't actually go erase anything.
Absolutely right. The way the technology is changing, nothing's going to be like it used to be. And there's no like firm and then the buyer and the seller. And it's basically we'll have to rewrite a lot of rules in economics as well.
For sure. A lot of the assumptions won't hold true. Same
Absolutely.
with who are the actors. It's not just people anymore, it's machines.
Absolutely.
We're going to have to create entire new concepts of how they do trade and how they work with us too.
That's true.
What kind of barriers or roadblocks would you imagine are going to happen in the blockchain space?
So at least when we talk about Bitcoin, there are some trust issues. There have been some hacks, and so there's obviously a need to work on trust and feeling that it's a safe technology.
Yeah, one of the problems that Bitcoin has faced is Bitcoin's getting stolen or lost, but a lot of that actually comes from people trying to re-centralize Bitcoin in different ways, making themselves actually a pretty easy target.
Absolutely. So education will be a big part before we actually can use the technology in a wide sense. Right?
Yeah. To actually transition into the mainstream and make it useful for average people to use, we're going to need to make sure we have a lot more education, a lot more standards, and probably work with a lot of enterprises to create sort of the user experience around this being a technology that is safe and usable and understandable. What is the current state of blockchain in your understanding? What's going to happen next?
The current state is the research state, and it's being developed to be applied in many areas. It might be used almost everywhere to where like we won't even imagine how we live without it. But I'm not sure where it's going to go. I mean, no one really knows, right?
Well, we have a lot of public blockchains. Like we have Bitcoin, we have the Ethereum network, NXT, but a lot of companies and consortiums are getting together to build private blockchains, so ones that are more closed off at first and then may evolve into a public network when people feel comfortable using it. And some are also proof of concepts out in the real world, projects in energy and in pharmaceuticals and in retail and lots of different fields are starting experiments. And we'll see in the next few years how all of those interact and what we learn about the best use cases for blockchain and what it means for trade. So tell me your version of a technical definition of blockchain.
A technical definition of blockchain.
All right, so here we go. So that was the grad student. I didn't want to pause it in case you were really into it, but so it seems like for the more complex we get, we're not learning any new concepts around the idea of blockchain. Rather, what's going on is we're learning more about what it can do in every specific application or in different use cases. And that seems to be pretty interesting to me because the more, as a baby blockchain developer myself, one of the big questions that I've always had is the different use cases for this type of technology. And it seems like there's no real, there's no standardized, we have this use case, and this, and then that's it. It seems like people are coming up with more use cases every day. And that's kind of interesting. It means that there's probably also ways that we can create utility beyond what's even been imagined right now. And that could be really interesting and probably very lucrative as well. I heard a story of someone who made a coin this past Monday, and already it has about like a $15 million market cap. And that seems kind of insane. In fact, it is rather insane for something to get that much value that quickly. And you can create it rather easily. In fact, I'm going to make a smart contract in a little bit, so stick around for that. But here we go. It's the final explanation for all of you big brain wizards watching. What is blockchain in the most technical way that we can explain it from a historian at New York University? A historian. I wonder what type of history. All right, let's see.
Is a persistent, transparent, public, append-only ledger.
All right, so this guy, he's not just a historian. He must be like an internet historian or something like that. All right, let's see. Let's keep going.
So it is a system that you can add data to and not change previous data within it. It does this through a mechanism for creating consensus between scattered or distributed parties that do not need to trust each other, but just need to trust the mechanism by which their consensus is arrived at. In the case of blockchain, it relies on some form of challenge such that no one actor on the network is able to solve this challenge consistently more than everyone else on the network.
So it randomizes.
Yes, yeah, it randomizes the process and in theory ensures that no one can force the blockchain to accept a particular entry onto the ledger that others disagree with. One that relies on a mechanism for a peer-to-peer network that can maintain updates to the ledger and then verify those updates in such a way that it is impossible to defraud and impossible to alter after the fact.
And do you see it as defining a new discipline of kinds, or where are we going to see blockchain emerge in the real world first?
I mean, just so like as an example, one thing that I think about a lot in terms of possible blockchain applications is electricity. Right, the next generation of distributed smart grid technology, effectively.
Sure, and people are working on that
yes,
already.
Yeah, exactly. And it's this very fruitful area of research, and you can find yourself looking like 20 years out, right, where you have an enormous number, like, of electric cars. You have all of these batteries. Like, that's essentially a distributed.
Hey, since it's only May, that's one of the ideas that I've had for a while too. Is when you think about what the future of money is going to look like, and or the future of asset classes in general, and you wonder what is the thing that's going to be very valuable in the future, no matter what technological improvements happen or no matter what new gadget comes out. It's always seemed to me as if the most important thing to have in the future is going to be energy or electricity, and having some sort of crypto that you would be able to turn in or trade in for electricity. So that would be rather interesting because one, it's not limited, or it's not, but it is scarce. There's not a finite amount of it, at least not any finite amount that we'll ever be able to tap into, because there's plenty of energy in the universe, at least for the short to medium term, like, billions of years in the future, whatever. But if you had a cryptocurrency and you were able to exchange that like 1-to-1 for a kilowatt hour, or like just a 1-to-1 transfer for crypto and you get electricity back, now we have a currency that is backed by something that has real utility. And not only that, but also you can sort of control it based off of the production capabilities, and maybe different people could find their own different ways of producing things, producing electricity, whether it be with a solar panel or, I don't know, miniaturized nuclear power plant or something of that nature. But I've been toying with this idea. I don't know if it's a good idea, but they seem to be thinking about it, and they seem to be thinking about it in the context of a power grid, meaning the same way that the network is regulated in a blockchain sense, we could also regulate the electric grid in that sense. And I guess I don't know how you would do that without exchanging some sort of crypto for energy, because there has to be a request and response cycle going on. So the request could be me sending a token that has my verified signature on it, and then the response could be energy. And could that be done in a distributed manner so that no one person has a centralized, I guess, authority over the energy? That would be a major paradigm shift compared to what we have now, where you have like the utility company, or you have the electric company, you give them money, they send you some electricity back. And then who deals with the infrastructure for all that? I don't know. Anyway, it's an interesting question, and I'm curious. I don't know, see what else they say about it. Curious what you think about it too, Chad.
Peak load power grid, right? Like the cars are getting plugged in and unplugged at different times. If you have a mechanism that is
Going to the chat real quick, is real James blockchain practically is evolving? Yeah, no, it literally is evolving, and it's really interesting to think about the next sort of steps of this. Maybe this historian, by looking in the past, can tell us about the future. Let's see what he thinks about it.
Able to automatically and autonomously be distributing power based on batteries that are scattered throughout the grid, that are being used for other purposes. Their owners don't even necessarily need to be aware. You begin to have something that looks like a much more viable society that still has a lot of electricity needs, but is able to base that much more on renewables, is able to make up the difference during peak load periods or during differences in weather, that is able to have power much closer to where it's needed rather than having to be distributed over great distances. Like, that's something that would be an enormously hard problem to solve. And it's not that the blockchain makes it easy, but it makes it possible.
A lot of people are seeing blockchain in the news and maybe seeing a lot of sort of initial coin offerings, this sort of monetization opportunity around blockchain, and are getting very excited about it. And some of that excitement is real and should be, you know, encouraged, but some of it is also hype. How do you feel about the hype cycle around blockchain today?
I'm glad you mentioned initial coin offerings, because for me those really exemplify the sort of the problem that we're having at this exact moment. They are an idea with enormous potential significance.
Since this person is a historian, I want to give a little bit of history on this. So this video was done when? It was done November 28, 2017. And I believe, if I'm not mistaken, you can fact check me, but I'm right. At November 28, 2017 was like literally when we were about to get that first huge crypto rush. And the first one was when Bitcoin got to like, I think $20,000, and that got, what was the phone ringing? Anyway, sorry. So it went up to like $20,000, and then it went back down to like $5,000. But it was like right now. And it seemed like everyone was doing an ICO. There was all these different companies that may or may not have been real, doing an initial coin offering. And then people were buying it, pretty much speculating that, you know, maybe one of these things will work out. And it was quite the bull run all the way up to, I think, January. So it was a short window. And I only know this because I had the I guess, baptism isn't the right word. The initiation into cryptocurrency was me making a bunch of money one day and then the next day seeing it all disappear. And that is always going to be stuck in my memory as my favorite trading time, because it was one of those gifts and curses, because it was really interesting and I did actually make some money. But then also, by the time I had gotten around to telling everyone else about it and then they bought in, that's when the price dropped. So now I look like a jerk. But still, if they had held, it would have been great. Anyway, so this is kind of what's going on here. All right, let's keep going.
Significance down the road.
That's right. I stopped it to tell you about the history. He's talking about ICOs. These were very much in vogue at this time. Let's keep going.
However, the promise of the initial coin offering has been kind of hijacked into this string of like basically pump and dump scams or sort of desperate gold rush schemes. The faster that we can shift from this fantasy that it is going to make you rich in a sort of, you know, 1920s tulip bubble kind of way, is the sooner that we can get into people, honestly, and I mean this like with all the hope in the world, people being disappointed in blockchains. Like, oh, I didn't get rich. It's just being used now to make it easier to transact goods and services safely across borders. This isn't exciting at all. And then we'll see that like become part of the everyday infrastructure of the world in a way that I think will be very significant. But I think it is now almost every aspect of it that's connected with the concept of money is wildly overhyped.
Well, and it also creates a problem, which is people get a lot of excitement around it, and then they're waiting for the world to change, right? Where is this technology? Why haven't I seen anything change yet? And it's because we've had a lot of PR, a lot of proof of concept, but truthfully, this is more like a science, right? It will develop, it will take 5 years, it will take 10 years. That kind of time is necessary.
It will evolve.
One of the areas that
Israel James
brought me to supply chain research is the fact that we're not just going to see blockchain emerge. We're going to see artificial intelligence continue to evolve. We're going to see connected devices and this sort of growing Internet of Things, machinery that can do a lot more and have a wallet and transact on their own. And so I actually think a lot of where blockchain and other technologies are headed is this interesting synergy that will help us elevate the kinds of institutions we've used in the past and cobbled together to create that identifiable, verifiable trust.
Yes, and one of the most interesting ideas to me that came out of the currency side of the blockchain project was the notion around like coloring coins, right? Assign properties to a particular coin, and in particular to assign those properties in ways that would allow you to do things like bring in the graph of previous transactions.
Right.
You know, there's sort of an obvious application for this, which is something that would look a little bit like an extreme version of like a boycott, divestment, and sanctions kind of approach, right? A model where it's sort of like, I will not touch money. My wallet will automatically not touch money that has been exchanged with the following, as a sort of very extreme way of cutting those things out. But there's also ways in which I think that could be applied to clearing out the entire logistics process of many kinds of bad actors. But trying to make a supply chain better in some ways relies a lot on whose version of better that is and exactly kind of what gets qualified, but also how that is quantified within, say, some kind of like smart contract system. There's multiple ways that I can see this backfiring, and one is the ways in which that is implemented, for example, leaving certain kinds of bad behavior untouched or unanalyzed, or one that feels even more dire to me in some ways is creating an extremely inflexible because human contracts, legal contracts are actually very flexible. Like there's a lot of kind of room to move and renegotiate. But we already have real world versions of some of these nightmare scenarios, right? Where like your kid has a medical emergency and you can't unlock your car because you're 2 days behind on payments for it. And so the car system will no longer respond to the app mechanism that you're supposed to be able to use to drive it.
So a barrier being sort of a rigidity in those structures that maybe don't accommodate real life scenarios very well.
As you and I have been talking, one of the things that keeps coming up is that we tend to hold novel technologies to an unrealistically high standard in terms of what they are supposed to deliver, rather than comparing them to actually existing systems where we can begin to see the possibility that even like a slight incremental improvement would still be an enormous gain.
The system we have today is also broken, right? And that it's hard to compare it to some perfect future, just like we compare autonomous vehicles to this very high standard. Because machines are doing it, it should be perfect, right? There should be 0 car deaths. When you say, well, there's hundreds of thousands, millions of car deaths on the road due to human error today, I think we're in a similar place. We're going to see problems with this technology, and we are going to need to develop multiple kinds of standards that also have some flexibility. But it's going to also be a version, a system that allows us to fix some of the things that are broken today. Blockchain may sound complicated, but at its core, it's just another tool for humans and eventually robots and other kinds of identities to trade at scale and make that trade more decentralized.
Humans, robots, and other types of identities. Huh. What does she know that I don't know?
Centralized. And it's part of our future. So it's important that people have these kinds of conversations and start to learn about it.
All right. That was good. Good. Now you understand what blockchain is. No matter what your level of expertise was before, now you should have a pretty good idea, right? I think so. To sum that all up, blockchain is a way for me to send something to you, and then there's a record of it. I don't know. I don't know if you need to even go much deeper than that, but that's kind of what it is. I mean, of course you do, but that's kind of what it is in a nutshell. So that's blockchain explained, 5 different levels. And now let's go ahead and get into creating a smart contract. And we heard about contracts there in that last video. So what does that look like? And let's go ahead. First things first, I need to get rid of this and make myself huge again. My dogs, what up? If you're wondering what's over here on the TV, that's actually me in 10 years. Not really. I hope not. Well, no, it wouldn't be that bad, actually. My bad. My bad to that dude. Here we go. Crypto zombies. Should I share audio? Yeah, why not? And here we go. All right, let's make sure that it is nice and big for you. It wasn't. Here it is. All right. And can I make this much bigger? I don't know. Let's see here. Here we go. I'll zoom in super far, and then I'll look on my phone, and then I'll see if it's actually working, and then I'll know. Or you can just tell me. All right, here we go. I'm about to make it bigger. It's because of the lag. I can't tell instantly. And let's see here. Did I do it? Yeah, okay. Okay, there it is. You should be able to see that as long as you're on your computer and not on your phone. If you're on your phone, you have to probably look real close. Anyway, starting with the absolute basics, Solidity's code. By the way, we're coding in Solidity, and Solidity is a programming language that you code blockchain applications in. You can code smart contracts in it and all of that sort of stuff. And actually, it's really easy to make a smart contract. So let's go ahead and run through this. A contract is the fundamental building block of Ethereum applications. All variables and functions belong to a contract. I'm going to assume that you know something about programming, by the way. So if you don't, then enroll at Make School. Yay, Make School. And if you do know something about programming, then maybe you'll have some fun watching me do this. So Solidity's code is encapsulated in contracts. A contract is the fundamental building block of Ethereum applications. All variables and functions belong to a contract. And this will be the starting point for all of my projects. An empty contract named Hello World would look like this. Contract Hello World. It's not too bad. So it would look like this. You're saying contract Hello World. I guess we'll do... What's it called when all the letters are capitalized? Title case, maybe? Version pragma. All Solidity source code should start with a version pragma. Declaration of the version of the Solidity. I'm going to like speed read it, by the way. So, because I've kind of done this before. And you can read it. So I'm going to speed read it. A declaration of the version of the Solidity compiler this code should use. This is to prevent issues with future compiler versions, potentially introducing changes that would break your code. For the scope of this tutorial, we want to be able to compile our smart contracts with any compiler version in a range of 0.5.0 inclusive to 0.6.0 exclusive. It looks like this. Pragma Solidity. It looks like that. Let's grab it. And also, there's a little bit of trickiness here that they're not going to tell you about, but there's a period at the end here. And if I leave that period in, I'm going to have a bad time. And let's get rid of it. There it is. All right, got rid of it. In case it was right there, and I got rid of it like that. Okay. So if you copy paste it, make sure you get rid of this dot at the end of the period. Putting it together, here's a bare bones starting contract. The first thing you'll write every time you start a new project. By the way, I've never done this before. I've done other tutorials. I've never done this Crypto Zombies one. So I hope it works. So it looks like this. Okay. Yeah, that's what mine looks like, except I have better commented code. Yay me. To start creating our zombie army, let's create a base contract called Zombie Factory. Oh, okay. So I'm supposed to actually do this, I bet. I can't just make Hello World. All right. So let's make a Zombie Factory. In the box to the right, make it so our contract uses Solidity. Okay. That's what we're doing. Create an empty contract called Zombie Factory. Okay. We did that. When you're finished, click check answer below. If you get stuck, you can click hint. All right. Check answer. Am I right? Victory! I have triumphed. Solidity cowers in front of your might. I think that's a good way to put it. Lesson unlocked. All right, next. State variables and integers. Great job. Now that we've got a shell for our contract, let's learn about how Solidity deals with variables. State variables are permanently stored in contract storage. This means they're written to the Ethereum blockchain. Think of them like writing to a DB. Standing for database, I bet. Contract example, uint, my unsigned integer equals 100. In this example contract, we create a uint called my unsigned and set equal to 100. Okay, so all it is that. Okay, the uint is an unsigned integer, meaning the value must be non-negative. I wonder what unsigned means. There's also an int data type for signed integers. Okay, here's a note. And Solidity U is actually an alias for U at 256 by an unsigned integer. I don't think we have to worry about that too much. Okay, put it to the test. Our zombie DNA is going to be determined by a 16-digit number. Okay, declare a uint named DNA digits and set it equal to 16. Okay. Uint. Let's see here. I just looked at it. I immediately forgot what it looks like. Okay, uint. Okay, that's what I thought it was going to be. It's going to be called DNA digits. Oh, digits. Let me spell digits correctly. Digits equal what? 16. Okay, and that's it, right? Do we need a little John at the end here? All right, let's put that John at the end. And did I do it? Yay, Solidity cowers again in front of my might. All right, let's go to the next one. I wonder if we'll actually deploy math operations. Boo. Math and Solidity is pretty straightforward. The following operations are the same as in most programming languages. X plus Y, X minus Y, X star Y, X slash Y. Modulus, X modulus Y. Okay. Solidity also supports an exponential operator with star 2. Yeah, that's about what we would expect, huh? To make sure a zombie's DNA is only 16 characters, let's make another U equal to 10 to the power of 16. That way we can, that way we can later use the modulus operator to shorten an integer to 16 digits, creating U in DNA modulus. This is actually pretty cool how we're doing this here. So I need something called DNA modulus. I need to set equal to 10 to the power of DNA digits. I could just do 16 here, but we'll make the code, we'll make it prettier. Okay. All right. I think that's good. Let's check it. Yay, we did it again. All right, let's go through the next one. Let's see if I can get through all 15 of lesson 1 before the end of this. All right. Sometimes you need a more complex data type. For this, Solidity provides structs. So we can make a struct. This kind of looks like an object, huh? Structs allow you to create more complicated data types that have multiple properties. Sort of like an object, I guess, huh? Note that we have just introduced a new type, string. Oh, I did not note that. Thank you for pointing that out. We did. String, name. I wonder what that's going to be used for. Okay. String greeting equals hello world. All right. Put it to the test. In our app, we're going to want to create some zombies, and zombies will have multiple props. So this is a perfect use case for a struct. Create a struct named zombie. Okay. Our zombie struct will have 2 properties, name, a string, and dana, a uint. Okay. So we want to create a... You know what? I'm going to get rid of this start here comment, even though it is kind of nice. As soon as it lets me type in here. Or let me delete this. What's going on here? Why can't I click over here? Is it me? Is it my fault? Or is it the encode editor? You never know. Whatever. All right, let's do it. So we need a struct. And we need to call it what? I forget already. Oh, we need to call it zombie. That's what I was going to guess. So we need to call it zombie. And then we go like this. And then we need to do... What do we need to do again? A name, which is a string, and DNA, a uint. So let's do the uint first. Or should we do name first? No, we'll do DNA, because you get your DNA before you get your name, I would assume, right? I don't know. All right, let's go with uint. DNA equals, I don't know, equals, huh? How do we do it? We don't have to put equals anything. We just declare it. Okay, makes sense to me. I was wondering. So let's just declare it. Bang, and then we need a string, which is going to be called name. Okay. All right. So we have DNA digits, DNA modulus, an object, or a struct, a structure called zombie, with has a DNA and a name. Cool. Cool, cool, cool. Let's go to the next one. Check answer. What? I did it wrong. No. How did I do it wrong? Was I supposed to make it inside the contract? I think so, right? I need a uint named DNA and a string named name. What did I do wrong? Do I care that much, or should I just get the answer? Show me the answer. What did I do wrong? What just happened? Is this the answer? What's going on here? Wait. Okay. Okay, so it's like really small over here. Upper camel case. Oh, it's called upper. Oh, Ponderasti. Yay, Ponderasti. Isn't the guy on the TV Charles Hoskinson? Yeah, it is actually. How did you know that, dude? You're so smart, Ponderasti. Okay. Yeah, he was talking about Cardano. I was looking for like, what should I string name? Oh, they want me to flip him around. That's what they want me to do. I knew I wasn't Okay. See, this is what happens when you do these tutorials and you try and do something a little bit different. They just freak out and they say, no, you're wrong. I don't think I'm wrong. I think I just was doing it my own way. And I also can't click around it like I would like to. String name. That's what I'm doing the Udemy course. All right. Now I'll just get rid of this one. Now we should be good. Try again. Okay, that's what I had to do. I had to flip him around. I don't think it actually matters in real life. Maybe it does, actually. Maybe that's a good thing they made me do that. Anyway, Solidity cowers again. Let's keep on moving. When I want a collection of something, I can use an array. There are two types of arrays in Solidity, fixed arrays and dynamic arrays. Array with a fixed length of 2 elements, and an array that can another fixed array. Oh, it can contain 5 strings. So this is a really strongly typed language, meaning we have to tell it what we're about to do before we do everything, which, it's just what it is. A dynamic array has no fixed state. Okay, uint can keep growing. I guess a dynamic array, I can put whatever I want in there as well, I'm guessing. I can create an array of structs. Using the previous chapter's person struct. Okay. So we have person, bracket, people. Person, bracket, people. What's the plural version of zombie? I don't know. Remember that state variables are stored permanently in the blockchain, so creating a dynamic array of structs like this could be useful for storing structured data in your contract, kind of like a database, public arrays. You can declare an array as public, and Solidity will automatically create a getter method for it. The syntax looks like this. If you don't know what a getter and setter is, go to make school and learn about getters and setters. Other contracts would then be able. It's like some. Should I? Yeah, why not? We have time. A getter. Well, a setter is like sets information, and then the getter gets the information. That's kind of like the quick version, quick and easy. Other contracts would then be able to read from, but not write to this array. So there's a useful pattern for storing public data in your contract. Okay. All right. So create a public array of zombie structs and name it zombies. Okay. So where should I put it? I guess I'll put it under my zombie struct. I wish I could click in here. Okay, here we go. Okay. I think one of the problems is there's like 5 different windows in here, so I can't click around like I would like to, because they all have their own little scrolly bar, I think. And I can't get rid of this hints thing. I don't know. And I'm on Google Chrome. Normally, whenever I have browser issues, people are like, oh, are you using Google Chrome? And I'm like, no, I'm on Safari. And like, oh, that's why. And then normally they're right, because then I go over to Safari and it works just fine. I mean, I go over to Chrome and it works fine, but here I am on Chrome. Who can figure it out? Okay. Yeah, this hints thing just won't go away. Anyway, so we want let's see here, zombies, and we do it like that. Oh, no. We need to do it. We need to do zombie, and then this, and then I think we call it zombies. Like that. Nothing is changing color though. Very suspicious. Did I do this right? Person, public, people. Okay, so maybe zombie, public, zombies. As soon as I can click over there again. Okay. Zombie. Isn't it public by default? Am I right or wrong? Zombie, public, zombies. Okay, that changed color. That makes me happy. Put it to the test. Create a public array of zombie structs and name it zombies. Okay, so this did want it to be public, so let's try it out. Oh, I got it. Yay, me. I'm the best. Okay, so we have that. And let's go ahead and move to the next one. Function declarations. A function declaration in Solidity looks like the following. Function, eat hamburgers. Someone was hungry. String, memory, underscore name. So 3 arguments, huh? And then uint, and then amount, and public, and then open and close curlies. That is quite the function. String, memory, underscore name, comma, uint, underscore amount. Okay, so 2 okay, what's going on here? This is a function named eat hamburgers that takes 2 parameters, a string and a uint. For now, the body of the function is empty. So it takes two things: a string, I guess memory has to be in there, and then underscore name, and then a uint. So uint and then underscore amount. So name is going to be the string, and amount is going to be the integer. It's going to be public, and we put public after the parameters. Oh man, I'm making myself yawn. All right, this is a function named eat hamburgers that takes two parameters, a string and a uint. For now, the body of the function is empty. Note that we're specifying the function visibility as public. We're also providing instructions about where the underscore name variable should be stored in memory. This is required for all reference types such as arrays, structs, mappings, and strings. What is a reference type, you ask? Well, there are two ways in which you can pass an argument to a Solidity function: by value, which means that the Solidity compiler creates a new copy of the parameter's value and passes it to your function. This allows your function to modify the value without worrying that the value of the initial parameter gets changed. Or by reference, which means that your function is called with a reference to the original variable. Thus, if your function changes the value of the variable it receives, the value of the original variable gets changed. You got that? By value or by reference. Those are the two ways. I'm not really sure what all that means, but no, it's convention, but not required. Just start function parameter variable names with an underscore in order to differentiate them from global variables. We'll use that convention throughout our tutorial. You would call this function like so: eat hamburgers, Vitalik 100. So he's going to eat 100 hamburgers. Good for Vitalik. Put it to the test. In our app, we're going to need to be able to create some zombies. Let's create a function for that. So we'll create a public function named create zombie. It should take two parameters, underscore name, a string, and underscore DNA, a uint. Don't forget to pass the first argument by value by using the memory keyword, and put your tray tables back to the upright locked position as we prepare for a landing. Okay, here we go. Big time, big time. Okay, let me just click in here. Let me get to where I can move around. All right, so we have our zombie thing here, and let's go ahead and move over. So we need a public function named create zombie. So I think we started with the word function, right? And then we put in some parameters. Let's see if I can 360 no scope this from memory. So we needed a string that we call from memory, and it needs to be underscore name, right? Name. Yeah. No, I'm good. Okay. And then we needed uint. And then what was that other one? I think there was only two, right? Uint. And I think just what it's called, right? DNA. And then we need to make it public and then just make it empty, right? Send it. Let's see what happens. Check answer. No, I got it wrong. In public. No, how is that possible? Did I not name the function? I probably didn't name the function. Yeah, I didn't name the function. Okay. I was getting ahead of myself. So it needs to be called create zombie. Okay. See, if I was pair programming, you, dear viewer, would have been able to catch that. So it's called create zombie, you say. Create zombie. Zombie. My bad. Okay. Oh, no, don't show me the answer. No, I meant try again. Okay, try again. Yay, I got it. Victory. Solidity cowers again in front of my mic. Halfway through, after we get done this next one. Well, we're like, I don't know. Yeah, halfway through. Create new structs. Remember our person struct in the previous example? I do remember. It was just a few minutes ago. Now we're going to learn how to create new persons and add them to our people array. Persons, Satoshi equals person, 172 Satoshi. People.push Satoshi. So we use .push, it looks like. Do we use .push in JavaScript too? I guess we do. Okay, we can also combine these together and do them in one line of code to keep things clean. People.push person 16 Vitalik. Okay, let's not get crazy here, crypto zombies. .push adds something to the array, end of the array, so the elements in the order we added them. So it's like append. Put it to the test. Let's make our create zombie function do something. No. Okay, so fill in the function body so it creates a new zombie and adds it to the zombies array. Now I'm going to have to look at this because it's getting a little tricky now. Asking me to do a lot. Okay, so let's see here. Comment has been, it's along for the ride. We're going to keep it. Fill in the function body so it creates a new zombie and adds it to the zombies array. The name and DNA for the new zombie should come from the function arguments. Let's do it in one line of code to keep things clean. Okay. All right, let's do it. So we just need to, can I no scope this? I don't think so. What's the struct called? It's called zombies, right? So I should be able to do like zombies.push, right? Yeah. So I should be able to do. Let's try it. Let's try it like this. Once it lets me click in here. Okay. Try zombies.push. Not uppercase, lowercase has to be, I'm sure. I think, right? Let me just make sure here. Yeah, push. Okay, zombies.push. I think it's zombies. Or is it zombie? No, it has to be zombies. Or should I do it like person, public people? Okay, I have that. Okay, so I don't do zombies. I have to create a new zombie. So I have to do, okay, so I have to do it all in one line of code. So I do, no, I'm right. I am right. It's zombies.push, and I'm pushing Satoshi. So I got to push a zombie. Okay. Because look, this is what I got to do, right? I got to push a zombie that takes in two parameters, and the first thing is called a name, and the second thing is the DNA thing, right? So it should come from the function arguments. So we should probably, since we've named it underscore name, so we need to do, let's see here. I'm going to push a new zombie. Let me get this cursor over here. We need to put in, let's see here. We need to do underscore name. And we need to do underscore, what is it called? Did I name it? I think it's just underscore DNA, right? I hate this in browser editor. I really do. Okay. Let me zip on over. If any of you have done crypto zombies like Ponderosity, could you tell me if this happens to you as well? Or is it just a me thing because I'm live on stream? So it should be like that, and that's all in one line of code. Do I have to make anything public, or do I have to do anything crazy? I don't think so. They didn't. It's already done. The only thing I didn't do is add a what's this called again? Semicolon? You call it a semicolon or a semicolon? Semicolon. 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 All right, bang, and let's check answer. Yay, I did it. We're not going to get it done by 8 o'clock, but hey, we got halfway done. That's kind of normal for programming. Let's see if we can do one more before time elapses. Private public functions. In Solidity, functions are public by default. Anyway, this is kind of what it's like to code in Solidity. I hope you're enjoying this. But as you can see, it's really not that hard, especially if you have some experience programming before. And I guess by the end of that, you can deploy a smart contract. And what was I working on before? Can I show you? Can I share my screen? Yeah, I can share my screen. Yeah, I'm not going to do this. Instead, I'm going to use the last bit of time here to share my screen. So let me go here. I'm going to get rid of that. Cool. And let's see here. Man, I should have asked chat, like, if you can guess who this guy is, then you win something. And then, actually, I'm going to do it. If you can guess who this guy is, then you win something. And who guessed it? Ponderosity guessed it. Yay, he got it right. Charles Huskinson. It says it on there, I think. But there's no way you could see it from there, right? Yeah, you can't see that. So, yay, you win something, Ponderosity. You win ice cream. So, next time you see me, you have 2 ice creams coming your way. All right. What was I doing? I was going to share my screen. Stop screen sharing. Let's share it again. Do it again. Do it again. Turn off my robotic brain. Oh, I forgot to hit. Here we go. Ready? So this is kind of what it looks like, not in crypto zombie world, but in real world. Let me find it. Just had, and it disappeared on me. Do it again. Do it again. Do it again. Anyway, this is kind of what it looks like because you start using async await, and you know what that is, of course. And then we have an inbox here, and this is for the Udemy thing, so you can, of course, do math. You know, we have these public functions. This is not public because we want to do math on the inside. We have a set message. We have this inbox here. This is kind of like creating a Solidity inbox. And when you actually code this, you're going to get all these squiggly lines. And I've been told to not worry about those. So if you start coding in Solidity and you get these red lines under your pragmas, then and it's going to have this error on it in VS Code. Don't even worry about it. That's what I've been told. And then we have our test files. So, you know, we're all about test-driven development. And then we have this, which is like some basic like car and drive, and we're testing with Mocha, of course. You know, if you're an experienced MERN blockchain Solidity developer, then you probably know all this already. Actually, it's probably not going to help you. But if you're a MERN developer, but you don't know about Solidity, then this is probably cool for you. So here we go. Here's the compile code. This is all it looks like. I don't think it actually even needs anything else. That's too crazy. The only thing that really surprised me going through this was like we have to talk about the encoding, UTF-8 encoding, of course. We have our path.resolve. This is all like standard boilerplate stuff, and you know we have these require statements in here, so that's all good. Here's what deploy looks like. I haven't got there yet. We'll look at it later. And then here's all of our package.json stuff. As you can see, we don't need that many libraries. You know, we have Truffle, we have Ganache, and we have Solc and Web3. But these are pretty much, I think, the main squeeze of the dependencies that we need. And you know, this is kind of what a smart contract looks like. Like this, I'm getting ready to deploy it, and then I've deployed a smart contract. So it's actually pretty easy to get started with Solidity. I'm not sure if you got a good taste of it by watching me do the Crypto Zombies thing, but go through the Crypto Zombies thing and then tell me if worked out better for you. Let's see here. Join the Discord. Yep. Now I'm going to do the part where I start flashing the stuff on the bottom. So anyway, it's 8 o'clock. That's enough Solidity for today, I think. Thank you all for upper camel case. I got to remember that. Thank you all for coming, and I hope you enjoyed. I hope we all learned something about blockchain. I hope we all got a little taste for what it looks like to code in Solidity. I know, like, literally last week, I didn't even know what Solidity was or what the blockchain programming language was, and when I'd ask people, they'd tell me like Ethereum, and be like, yeah, I know Ethereum, but Ethereum to me is something I buy. It's not something I develop with. So how do I make that work? And let me go back to full screen. It's something I buy. It's not something I develop with. And then I had to figure out that Solidity. Anyway, I hope you enjoyed today's episode. This might be the last episode for a little while because it is summer break. And I hope you enjoyed our time with Tech Topical. We might do another episode sometime soon, or I might do a different show. We'll have to see what the future holds. But I hope you all enjoyed. That was today's Tech Topical, Tech's best talking show, and there is none greater. And as I'm getting ready to sign off, it's a little bit bittersweet, but I very much enjoyed my time here with all of you. I hope you enjoyed your time with me. I don't know if it's possible that you enjoyed it more than me, but in any case, I'm happy it happened. So thank you all for watching. I will see you all sometime in the future. And I hope you enjoyed learning about blockchain and Ethereum. And before you forget, make sure you follow the Twitch platform. Make sure you subscribe on YouTube. Make sure you like it on Facebook. Follow us on Twitch at make_school. Join the Discord, make.sc/join-discord. Watch the past live streams, including the last live stream with Mr. Councilman Kurtz, which was a very good episode. You should watch that. And you can watch that at make.sc/watch archive. And you can watch only the Tech Topical episodes at make.sc/watchtt. And if you would like to learn how to code in general, go to make.sc/apply and apply to Make School. I hope you all enjoyed it. I will see you all later. All right, that was Tech Topical. Bye-bye. Brian Ross.